Let's begin. So today we're talking about problem solving. We're not learning any new skills. We're just taking the skills we've learned and looking at applying them to some real life applications. We will need to recap bearings here. Now some people have said, I don't remember that from year 10, and it may be because you learned that sort of right on the cusp of the tail of the term when the coronavirus really kicked in and people weren't coming to school. So a bearing, right, is an angle measured from straight north going clockwise. Okay, so if you had a bearing of 20 degrees, that would be it. If you had a bearing of 90 degrees, that would be it. Here we have a bearing, if we read the first sentence, we've got a ship leaves port with a bearing of 200 degrees. So that means from here, we're going around 200 degrees. Well, we know a straight line is 180 degrees on a straight line. So it's going to be just a little bit further. That's going to be 200 degrees there. So that's going to be the path of the first ship. All right, 200 degrees. And then we have the second ship leaves port at 165 degrees. And so if I'm thinking about that, I'm thinking, well, that's 90, and I know the whole way is 180. So it's going to be roughly somewhere in between there. It's going to be, 15 degrees from 180. So that's that one there. So that's 165 degrees, and then between here and here is 35, because if you go the whole way around, you sum to 200. 165 plus 35 will give you that 200 degrees.
Max.
Okay, so then we have ship A travels 5.2 kilometres in half an hour. And ship B travels 5.8 kilometres in half an hour. How far apart are they after half an hour? So I want you to go, how far apart are the two ships? So you can draw the diagram, and then like you don't have to do this, but an even easier way to think about it is to just subtract the triangle from the diagram with all of the information. We've got 35 degrees here, we've got 5.2 kilometres here, 5.8 here, and this is what we're trying to find. Now, when we're performing non-right angle trigonometry, we should remember for the sine rule, we use the sine rule for problems involving two sides and two angles. Two sides, two angles. And cosine rule will be three sides and one angle. So, as long as you have at least two sides and two angles, you can use the sine rule. And as long as you have at least three sides and one angle, you can use the cosine rule. Okay, so let's go ahead here. Here we've got three sides and one angle. So that means we're going to use the cosine rule. And I've said make the unknown side A, which means this is our angle A, and these are going to be B and C. And the cosine rule, when we're finding a side, it says A squared is B squared plus C squared. Take 2BC cos of A. Let's put all the information in and calculate that. So 5.2 squared plus 5.8 squared, take 2 cos of 35. Okay, and then to get x, we're going to square root whatever the answer is when we evaluate it. I did this earlier. I've got 3.356. Just 3.36. Should look at this. Excellent. Move on to the next example. We have A and B are locations 800 metres apart on a straight north-south road. Okay, so we have a road going from the north to the south. We have location A and location B, and the distance between them is 800 metres. Now, from A house has a bearing. Let's call the house C. The house is going to be location C. A house has a bearing of 125 degrees. So we know 90 would be the right angle. So 125 is going to be a little bit more than the right angle, isn't it? Okay, this angle here is 125 degrees. And that is some distance. We don't know how far it is. 2 point C. And then we're told, and if you go from B, house B, or location B to C, the angle or bearing is 50 degrees. Is that correct? Yes. Find the distance from A to the house. A is our house. And from B to the house. So it wants us to find both of these here. We call them X and Y. It wants us to find X and it wants us to find Y. Now looking at this is not quite enough information. We need to process it a little bit more to subtract all the information out of it that is necessary. So the first thing I'm going to point out is that this here is a straight line, okay? AB, that north-south line, is a straight line. And so if this angle is 125 degrees, it means this angle has to be 55 degrees because angles on a line add to 180 degrees. Now the correct way to make that statement is we're going to say angle BAC, okay, angle BAC is 55, and then the justification is angle on line. Okay, so if you've been doing spec, that's pretty fresh. If you haven't, you would maybe recall it from year 8 maths. All right, we're providing some justification. Now, so we've got that angle's 55. Then we can also find the angle at C, because we know that angles in a triangle also add to 180. So we're going to have angle BCA, or angle ACB, is 180, take 55, take 50, because of the angle sum in a triangle. Because all angles in a triangle add to 180 degrees. So we've got angle ACB is 75. So then, let's redraw the triangle, okay, removing the unnecessary features and putting on everything that we're going to need. So we've got 800, we've got X and Y, we've got 75, 55, and 50. Now for now, I might just eliminate Y, because we'll find them one at a time. We'll find X first. We'll find X first. So if I want to find X, I'm looking here, we've got 3 angles and 2 sides. Okay, we've got 3 angles and 2 sides. So we definitely don't have enough information to use the cosine rule. Okay, because the cosine rule says you need 3 sides. If we had a third side, then we could use either. We do have 2 angles. We've got more than 2 angles. We've got 3 angles. Anytime you've got 2 angles, you're going to have the third angle. And we do have 2 sides. So let's make the statement. We're using the sine rule here. This is going to be side A and angle A, and then our remaining angle and side, the ones with the information that we're going to input into the formula. So we're going to have A on sine A is B on sine B, and that's X. That's what we're trying to find. So we go X on sine 50 is 800 on sine 75. And crunch that. 634.4. meters. Okay, so that's how we're going to find X, and then we're going to repeat the process to find this distance here. Okay, so the distance from A to C is 634 meters, and it's pretty much the same process for finding C. You guys can have a go at that now if you like, but I'll stop there. Okay, so that's problem solving 6D. This is how you choose which sine cosine rule you're using, and to help you out, draw the diagram. That's what's really going to help you out. So let's get into it.